Okay.
Yes. Welcome back, all the participants and our guest for today, respected Sushma Gupta ma'am. Uh, I would like to give a brief introduction about ma'am. Ma'am has over 15 years of research experience, and she has published many research papers in renowned journals, both of national and international repute. She is the reviewer of the prestigious IEEE Transaction of Industrial Electronics, Interscience in Journals of Power Electronic Conservations, Institute of Engineers India Series B. She has received Best Paper Awards from IIT Madras, Chennai, and also at International Conference of Electrical and Electronics Engineering from Nagpur. She has guided many PhD scholars and at present she is guiding 5 PhD scholars under her. She has guided more than 15 MTech theses, and she is a life member of IEEE and ISTE. We are honored to have your presence, ma'am. She will be delivering a talk on low voltage right through LVRT in wind energy. Over to you, ma'am.
Thank you very much for inviting me and giving
Our
my
pleasure, ma'am, to hear you.
introduction. Uh, the topic of our FDP is the recent trends in renewable energy. नाइन आप अपना कैमरा ऑफ कर लें. Okay. So I think that I should deliver the lecture on wind energy because lots of experts will give lecture on solar and microgrid. So I think I should give the presentation on wind energy. So should I start the presentation?
Yes, ma'am. Sure, ma'am.
The topic my presentation is low voltage ride through techniques used in DFIG based wind energy. Is
Yes, ma'am, it is visible, ma'am.
you are visible? Okay. As more efforts are given to increase the use of renewable energy sources, you know, and preserve our environment, wind plays very important role, very major role to produce electricity. The wind is freely available, and with the modern technology, it can be captured efficiently. Okay, so uh, the outline of presentation, my presentation is. किसी का mic on है?
Yes, ma'am, it has been disabled. Please, the participants, kindly see that you don't open your mic because it is a disturbance for the speaker when
So
they are talking. Kindly take extra care of it. Ma'am, please, you can carry on, ma'am.
outline of my presentation will be introduction, comparison of wind and solar, wind turbine classification, double-fed induction generator based wind turbine, low voltage ride through, that is known as the LVRT techniques in DFIG based wind turbine, conclusion and references. This will be my presentation outline. So next, introduction. At present in India, use of renewable energy sources to generate the electricity is exponentially rising, and the target is that 175 gigawatt we should generate 2022. So this is the target, out of which 100 gigawatt electricity will be generated by solar, 60 gigawatt from wind, 10 gigawatt from biomass, and 5 gigawatt from hydro. So this is our target up to 2022. India's capacity to generate electricity through wind is 38 gigawatt. 38 gigawatt in the March 2021, and it is in the 4th rank in the world, and that is the 10% of total electricity generated by the India. In India, we are generating around 383 gigawatt total electricity generated, and this is the 10%, 38 which is generated by the wind. If we talk about the Madhya Pradesh, because we are living in the Madhya Pradesh, so generating capacity is 2,520 megawatt, and we are having 38 wind projects, wind energy wind farms in Madhya Pradesh, and the largest wind farm which is situated in Madhya Pradesh, that is Pritam Nagar at Ratlam district. The capacity of that wind farm is 327 megawatt. If we talk about the largest wind farm in India, that it is situated in Jaisalmer, and the capacity of that wind farm is 1600 megawatt, that is developed by the Suzlon Energy. If we talk about the world's capacity, so Gansu wind farm in China, that is the largest wind farm of the world, and its capacity is 20,000 megawatt. This is the large capacity, large wind farm in the world. And in India, 1600 megawatt Jaisalmer megawatt is the largest capacity of India, which is generated by the wind, that is situated in Jaisalmer. So this is the general information. And what is the wind vision? Our government wants to generate 200 gigawatt from the wind energy up to 2030. This is the vision of our Prime Minister. So there is a lot of scope to work in this area. Next, if we talk about, this is the state-wise and year-wise wind power installation capacity. Total capacity, I have told that 38 gigawatt is the total generated capacity, electricity generated by the wind farm. And Tamil Nadu is the largest producer, 9,000 megawatt. And our Madhya Pradesh, it is in 7th rank. We are generating around 2,520 megawatts. So this is, we are in a 7th rank. So we have to do a lot of work in this area. So this is the state-wise and year-wise wind power installation capacity. Windmills may be installed and onshore or offshore. You know, all of you know, wind farms that may be established onshore or offshore. What is onshore or what is offshore? What is onshore wind farm and what is offshore wind farm? Do you know? Onshore wind farm and offshore wind farm, because I seen Bansal's sir presentation. They have discussed onshore and offshore wind farm. So what is that?
Participants, please answer the query of Madam.
Okay. Ma'am, onshore is on the land and offshores are on the sea.
Okay.
Or in water.
So windmills may be installed in an onshore or offshore. First, we have developed the onshore wind farm, that is established or installed in a land, on a land or hills. And onshore, the first wind farm, wind turbine was built in 1887 in Scotland, and offshore wind farm was established in 1992, 100 years later. So there is a difference. So onshore wind farms are established or built in a on a land or on a hills, and offshore wind farms are established in a water bodies or in a sea or ocean or lake. So this is there are two types of installation. What is the difference between offshore and onshore? We know that onshore we establish the wind farm on a land, and offshore we establish the wind farm on a water bodies. So what is the what are the other advantages or disadvantages about the offshore and onshore? So offshore wind energy refers to deploy the wind farms inside the water bodies. We know that, and they utilize the sea winds to generate the offshore wind farms use the sea winds to generate the electricity. Okay, so these wind farms may have fixed foundation turbine or floating wind turbines. Fixed foundation turbine means in fixed water foundation turbine, foundation is fixed, but in a floating wind turbines, foundation is not fixed, it is floated on the sea. So this is the difference. We have two types of foundation on in an offshore wind farm. Fixed foundation wind farms are established at a shallow water level, means 20-30 meter depth of the sea, and floating wind turbines are established in at a depth or around 60 meter in 60 meter depth in a sea. So fixed foundation turbines are built in a shallow water where depth of the water is only 20-30 meter, and floating wind turbines are installed in the depth where we are having 50-60 meter water level. So but these floating wind turbines are in initial stage, it is not mature. Fixed foundation turbine wind farms are in mature stage. These are the photographs of fixed foundation wind turbine. Fixed foundation wind turbine, their foundation is fixed, and this is the photo of floating foundation offshore wind turbine. First, this offshore, this is the photo of first wind turbine, offshore wind farms, that is established in Dhansukudi in Tamil Nadu 2018. First offshore wind farms are established in Tamil Nadu in 2018, and the power generation capacity of this is 12 megawatt, and the costing is 300 crore. And these floating foundation wind farms are in initial stage. So this is not developed in India. This is an initial stage. This is the photograph of Jaisalmer wind farm, largest wind farm in our India. So this is the photograph of Jaisalmer, 1600 megawatt we are generating. First wind farm is developed in 1985, and in a Renewable, Gujarat. The capacity of that wind farm is 40 kilowatt, and that was connected to the grid. These are the general some photographs, and now come to the point. It is found that offshore wind turbines are more efficient compared to the onshore one. Offshore wind turbines are more efficient because we are getting wind waves. Speed of wind waves is high, and we get consistent in wind direction. Wind is consistent in direction, or wind flows in a particular direction. Direction is consistent, And offshore wind farms generate more electricity as per the installed cost, installed capacity, fewer because it generates more electricity. Offshore wind farms generates more electricity, so fewer wind turbines are required to produce same capacity of energy as the onshore. If we want to generate same capacity, electricity capacity, so we require few number of wind turbines in case of offshore wind farm, and more number of turbines are required in case of onshore wind farms, because efficiency is more, because we have wind most of the time and wind flow direction is consistent, so we will get more electricity. And offshore wind is stronger during the daytime. Offshore wind is stronger during the daytime, so it generates electricity when it is required, because most of the time we require electricity in daytime because offices are open and markets are open, so we want electricity in a daytime. So that is the match, generation as well as consumption of the electricity. Wind turbines capacity utilization factor is equal to the average output power divided by the maximum power capability. So offshore wind farms have higher capacity utilization factor than the onshore, because we can generate electricity most of the time, because we are having sea wind most of the time, so we can generate electricity most of the times. So if we see, the average onshore wind turbines produces around 2.5 to 3 megawatt, while offshore wind farms can generate 3.6 megawatt. So we can generate more electricity with the help of offshore wind farm. But we are generating the electricity in the sea or ocean, and requirement of electricity in a urban area, so we have to take that generated power to the urban area. So we have to carry that electricity through the cables. The cables are buried in an ocean floor. So there are some disadvantages also, because we don't have a skilled person to establish or to manufacture the offshore wind farm. In offshore wind farm, strong structure is required, strong foundation is required, because speed of the wind is more, and installation, if we have to establish strong structure or foundation, so definitely cost will be more. Tariff of this electricity is more, 7 to 9 rupees per unit, and compared to the onshore wind farm, tariff is 2.8 to 2.9 per unit. So that is costly, and there is a possibility of damage during storm and hurricanes. So frequent maintenance is required, and maintenance is costly and difficult also. And the main problem is because we have to take clearance from the ministry, so it takes a lot of time to take the clearance from the ministry. So there is a unnecessary delay, as well as cost is more. So these are the disadvantage. But wind farm, but we have large of potential. We have 127 gigawatt potential, electricity potential, which can be generated with the help of offshore. So it requires lots of research. This is the general information about the onshore, offshore wind farms. Next is what is the different, I want to discuss some advantage and disadvantages of renewable energy and the conventional energy. So what are the advantages and what are the disadvantages of renewable energy? Slides दिख रही हैं? Narayan? Is it visible?
Yes, ma'am. They are visible.
Okay. So what are the advantages of renewable energy like wind or solar, and what are the disadvantages of wind and solar. We can produce electricity domestically or at home and don't depend on the foreign energy, you know. And advantages that boost local infrastructure and economics, means we can the person belongs to the rural area, they get job for that installation or maintenance, so economy will be better, and have low operational cost because wind or solars both are available freely, so there is no cost is not involved like in a fuel cell or coal, so operational cost is less. We have backup power in case of emergency, if there is a grid failure or some problem, so we have a backup power in case of emergency, cut down our toxic air pollution, and that cannot be depleted. These renewable energy sources like wind and solar, they cannot be depleted. But the disadvantage is that consistency, they are not consistent, they are variable. Not all time we will get the this wind or solar energy, so they are not consistent power source. Rely on a government subsidy because cost of solar and wind are more. So if the government gives subsidy, then we can install, otherwise cost is very high. Use of solar panel and wind turbines are expensive to manufacture and install because they are very expensive. So these are the advantages and disadvantages of the renewable energy sources and conventional energy sources. And now just I want to show one slide of solar energy. What are the advantages of solar energy and disadvantages of solar energy? Everybody know. सभी को पता है कि क्या हमारे एडवांटेज हैं. Just for revision, or just so they are more predictable. Solar energy is more predictable compared to the wind. We can predict what is the time in which we will get solar energy. Solar panels can be installed or can be installed on the building, urban area or rural areas, suburban. They can be installed on a roof of the building. And once panel is installed, they require little maintenance. Panel maintenance requirement is very less, and it requires less spare compared to the wind turbine. If we want to install 1 megawatt wind farm, then we require 60 acre land. So compared to that, solar solar cells are required less power, less space to install, and solar panels don't make noise. Solar panels are cheaper compared to the wind farm, so every person can install solar panels on their roof, so that is available in affordable rate. And solar panel can be used either in a heat form or light form. Wind farm can from the wind farm we can generate only electricity. So these are the advantages of solar energy. But disadvantage, we cannot generate electricity in a night or cloudy region, and prices upfront cost is more. Despite of falling the solar panel, upfront cost is more. Upfront cost means after getting the electricity from the solar cell, we have to convert into AC, because generated voltage is not constant, that is 12 volt or 24 volt. So we have to use DC-DC converter to boost up the voltage. We require the inverter to convert that DC voltage into AC voltage, and we require some battery storage. So upfront cost is more. And maintenance, solar panel maintenance is not the problem, but problem is the maintenance in power converters, inverters, converters. Battery maintenance cost is more in case of other circuits. So, and efficiency is very less compared to the wind. Efficiency is only 15 to 22%. So these are the disadvantages of solar panel. We cannot produce electricity in night and cloudy area, where wind, with the help of wind, we can generate electricity day and night, and efficiency is more. 60% of the kinetic energy is converted into the power. It consumes less power and produce more energy. If we talk about the space, so wind turbine can generate the same amount of electricity as 48,704 सोलर. अगर एक कैपेसिटी, एक विंड टर्बाइन ले तो एक विंड टर्बाइन जितना इलेक्ट्रिसिटी जनरेट करेगा वो 48,704 सोलर पैनल्स जनरेट करेंगे. सो more solar panels is required, and we have to have only 1 or 2 wind farms to generate the same electricity. Wind turbines can be built in offshore. You can establish in a water bodies. So this is the advantages of wind turbine, wind energy. But you know, this is very unpredictable, you know, and susceptible to damage from the lightning and wind. Take lot of space and create visual pollution, and they can hurt the wildlife. This is the main problem. It generates a noise. We have to build or establish this wind farm in a rural area, or in a isolated plain or hill. So, and we require the power at a rural area or urban area. So we have to use the transmission line to take the power from wind farms to the rural area, urban area where we need the power. And it is very difficult to find out the perfect spot, because spot needs to be clear from any obstruction that can affect the wind. So site selection is very important in this case, and require the specialized person for the maintenance. So when we are having a clear space, hills, water bodies, then we can use the wind energy. Otherwise we don't use wind turbine, but efficiency is more, person involvement is more. क्योंकि अगर if we install solar plant at the roof of the house, then every person will involve in that, so problem will be more. So if we have hills or water bodies, then we have to prefer wind energy. These are the general information. Now come to the point of wind turbines. Wind turbines classification, we can classify it into four category. Fixed speed wind turbine, fixed speed turbine that generates the fixed frequency voltage, and that is directly connected to the grid. Limited variable speed controlled wind turbine, bound rotor induction motor with variable rotor resistance control, doubly fed induction generator based wind turbine, BFIG, WT, and the fourth one is the full variable speed controlled wind turbine. So these are the four category of the wind turbines. But W-fed induction generator based wind turbines are mostly preferred because it has many advantages: simple installation, low cost, variable speed, constant frequency. Variable frequency because wind turbine operates at a variable speed, and if we are using the W-fed induction generator, then we will have fixed output, fixed frequency output. This is the beauty of this BFIG, and that is why it is used widely at present. Okay, in independent control of active and reactive power. These are the advantages of W-fed induction generator based wind turbines. So this is preferred. What is doubly fed induction generator? All of you know a doubly fed induction generator. This is the circuit diagram of a doubly fed induction generator. We can fed energy, or we can take energy from the rotor side as well as stator side. That is why it is known as the doubly fed induction generator. Okay, so here the rotor of this doubly fed induction generator is connected with the wind turbine, and there is a gearbox, because rotor blades speed of the rotor blades is 10 to 15 revolution per minute rpm. जो rotation of the blade speed, rotation of blade speed is 10 to 15 revolution per minute, and we want to speed of DFIG 1000 to 1500 rpm. So we require a gearbox to convert this 10 to 15 rpm into 1000 to 1500 rpm. So gearbox is required. It is connected to the rotor, and stator of this DFIG is connected to the grid, directly connected to the grid. And there is a back-to-back voltage source inverter. We have back-to-back source converter. There are two converters, rotor side converter and grid side converter. Rotor side converter controls the active and reactive power. Controls reactive power. It delivers the reactive power and take the active power from the DFIG and achieve the maximum power capture. And GEC is used to control the active and reactive power delivered as well and maintain the DC link voltage. This GEC grid side converter maintains the DC link voltage, and this rotor side converter delivers the reactive power to the DFIG, because DFIG can operate in a subsynchronous speed as well as supersynchronous speed. If it is operating in a subsynchronous speed, then reactive power is required, and when it is operating in a subsynchronous speed, so RSC, rotor side converter, feed the reactive power and it generates the power which is fixed frequency and fixed voltage. If it is this DFIG or is operating in a super synchronous speed, then we can take the power from the rotor side also, and at that time we can feed the energy or power to the grid. So this is the role of rotor side converter and grid side converter. So this is okay, no problem, but the problem is that they are very susceptible to grid voltage dip and disturbance, because here stator is directly connected to the grid. So if there is a fault in a grid, so stator and grid side converter both are influenced by the sudden change. And due to this disturbance, there is a large rotor current, and there is a large DC link voltage. If there is a voltage dip, rotor current will be more, and if rotor current will be more, then DC link voltage will be more. So they can damage the winding as well as power converter. So in previous time, when there is a disturbance, when there is a grid voltage dip, we disconnect the wind farms to the grid, but that time penetration of wind farm was very low, so that was not be the problem. But at present time, we have large penetration of wind energy to the grid, so it is not possible. If we disconnect the wind farm from the grid at the time of disturbance, so there is a disturbance in a frequency, in a voltage. So there is a inrush current and DC link voltage. We can disconnect in the previous time, but at that time now we cannot disconnect the wind farm from the grid, because there is a problem in a system frequency or voltage, so it is ideal to make wind turbine stay connected to the power grid and provide the support during transient periods. So that the ability to ensure continuous operation during voltage dip and minimize resynchronization problem after the clearance fault is known as the low voltage ride through, LVRT. And at present scenario, enhancement of LVRT capability in wind turbine is important because penetration level of wind turbine is very large. So we cannot disconnect the wind turbine from the grid because they can due to that frequency and voltage both may disturb. This is the means stay connected. Wind turbine should stay connected with the grid even there is a disturbance and or voltage dip. So wind turbine should be connected with the transmission line or grid, that is known as the low voltage ride through capability. Sometimes in some research paper fault ride through is also mentioned. It is also known as the fault ride through. So to give the importance, LVRT, every government is providing the grid code requirements. So government of India or every government is providing the grid code. What is that? We have to connect that wind farm to the grid. Even there is a fault or dip in grid voltage. So low voltage ride through means at low voltage wind farm should be connected. So some rules are given by the government, that is known as the grid code requirement for the wind farm. So if we want to install the wind farm, we have to follow the grid code. What is that? According to the grid code requirement, overcurrent that is issued by the government. Overcurrent and overvoltage in stator and rotor should be restrained to avoid damaging the power converter. Speed of the turbine and electromagnetic torque should be properly designed for the safe operation. DC link voltage should be kept constant to ensure the desirable operation of rotor side converter and grid side converter. Sufficient reactive power is required to recover the grid voltage. Voltage and frequency should be regulated. So these are the rules that is issued by the government, and we should follow these rules if we want to establish the wind farm. To follow these rules, there are various methods which I will discuss in this presentation. Protection based method or external retrofit techniques, internal control techniques, and hybrid approach. So there are three techniques which we can use to enhance the LVRT capability. Is it okay? Bhupen, is it okay? आगे बढ़े?
Yes, ma'am.
Yes.
Yes.
Okay. So external protection based method or external retrofits techniques. So external retrofit techniques can be effectively solve the problems and enhance the LVRT capability to install by installing the device to effect. So we have to connect external instrument or external circuit to enhance the LVRT capability. So we can install the circuit at the rotor side, and we can install the circuit at a stator side. So if we install the circuit at a rotor side, then it is known as the rotor side external retrofit. If we connect the circuit at a stator side, then it is known as the stator side external retrofit. So rotor side external retrofit, crowbar method, DC chopper, series dynamic resistor, and DC link energy storage system. And stator side external retrofit, series dynamic braking resistor, reactive power compensator devices, fault current limiter, and series grid side converter. So these are the circuits we can use to protect our wind farm and as well as the power converters if there is a fault in a grid. So first I will discuss the crowbar method. In crowbar method, I think you know crowbar method. What is crowbar method? To protect our wind. In crowbar method, we connect a resistor. In a crowbar method, we connect a resistor. Crowbar circuit consists of a parallel resistance installed in a rotor binding and the AC side of rotor side converter. So basically crowbar circuit, here we connect a resistor through the diode rectifier and a SCR. Okay, so when there is a fault in a grid, we have a inrush current at a rotor side and we get more current over here. When there is a normal operation,
Hello.
Hello.
Slide is not changing, madam.
Okay. Now, is it visible?
Yes, ma'am, it is visible, ma'am.
So
Yes.
in a crowbar circuit, we connect a resistor through a diode rectifier and SCR. Where under the normal condition, normal operation, when normal operation, this circuit is disconnected. This circuit is disconnected. Crowbar circuit is disconnected. And when there is a overcurrent, controller gets the signal. There is a overcurrent. It will switch on the SCR. It will switch on the SCR, and this rotor is connected through the diode, crowbar circuit and SCR and back to the rotor. And at this time, this circuit is disconnected from the DFIG. And at that time, DFIG acts as an induction generator, and it will take the reactive power from the supply. So that control current will be controlled. Another configuration is parallel R and L crowbar circuit that is also connected between the rotor and RSC. That will control the overcurrent by consuming power over here and taking reactive power from the rotor side. So overcurrent will be protected. Z is the grid impedance. If we want to be, because calculation of this rotor is very important. So if we consider this grid impedance at the time of rotor resistance calculation, then we will get the accurate value of rotor resistance, crowbar resistance. So at the time of rotor overcurrent or DC link voltage, the crowbar circuit is triggered and low resistance path is created to high current to flow. In this operation, RSC is disconnected from the rotor binding by the closed crowbar switch. With the crowbar circuit triggering, DFIG is transformed into, I have told that one, okay, when there is a fault, this DFIG is converted into the induction generator and it takes reactive power from the grid. So we will get the converters and rotor binding will be protected. Calculation of rotor bar resistance, crowbar resistance or selection of crowbar resistance is very important, because we cannot take high value of resistance or or low value of resistance. So analytical So analytical expression. Analytical expression, you can find out the value of crowbar resistance, and the reference is given in 3. If you want to calculate the value of resistance, crowbar resistance, then you can refer this reference that is given in a reference 3. So we have to take grid impedance also into consideration to find out the accurate value of resistance, crowbar resistance. Next is the DC chopper. All of you know DC chopper converts DC into DC chopper. It converts DC into fixed level to variable DC. So that same principle is applied over here. DC circuit, DC chopper, here you know grid side converter, rotor side converter, and this is DC link capacitor. Chopper circuit is inserted over here. And what is chopper circuit? Resistor, IGBT switch, and a anti-parallel diode across the resistor. So under normal operation, this IGBT switch is open, and this circuit not come to in picture. This is disconnected. But as soon as there is a high voltage at the DC link, this IGBT switch will closed. And if this IGBT switch is closed, current will flow through the resistor, IGBT, and this DC link capacitor. So extra energy over here that will be dissipated in the DC chopper. So this part here we will have the constant DC link voltage, and there will be no damage. So this is the simple concept. We can use chopper circuit between the rotor side converter and grid side converter. Okay, so here, but problem is that here we can control only the DC link voltage. We cannot control the rotor side converter, that rotor overcurrent. We cannot control the overcurrent. We can control only the DC link voltage and maintain the constant DC link voltage. But it is not, the overcurrent cannot be taken care by this circuit. So modified DC chopper is used in place of conventional DC chopper. This is the circuit diagram of modified DC chopper. Rotor side converter, grid side converter, and here we are having the 4 switches: S1, S2, S3, S4. If you are able to see that register S3 and S4, this circuit is same as in a DC chopper. Only जो आपके जो changes हुए हैं, we are having that S4 acts as a diode, freewheeling diode, which are using in a conventional circuit. So here we are using extra S2 and S4, S1 and S2. This, with the help of this circuit, we can protect the RSC and GSC from the overcurrent and over voltage. When there is a over voltage, at that time resistor S3 and S4 will come into the picture and share the power. If DC link voltage is more compared to the threshold voltage, so this resistor S3, S4 will activate and dissipate the extra power and maintain the voltage over here. If there is a overcurrent, then S4, S3 will switch off, and S1 is also off, and current will dissipate through the S2. So over that extra energy is dissipated into this resistor, and current will flow from S2 resistor. So extra energy is dissipated through this S2 and resistor. So in this modified DC chopper, we should not require the fault current limiter as in case of previous case, because that in previous case we can protect the circuit from the over voltage only. So we have to use fault current limiter at the rotor side. But here this modified DC chopper can protect the circuit from the over voltage and over current both. Next is the series dynamic resistor. Series dynamic resistor. Here we connect a resistor. Here we connect a resistor between the output of rotor and RSC. No? Okay, so this is the series resistor that is connected in parallel with back-to-back SCR. Under the normal operation, this resistor is disconnected from the circuit, and this output or the rotor of DFI and DFIG is connected to the RSC with this back-to-back converter. But when there is a fault over current, these two devices will turn off and resistance come into the picture, and this due to this insertion of a resistor, over current will limit. So in steady state conditions, switches are closed, these SCRs are closed and series resistor is bypassed. But during fault conditions, switches are open and a series resistor is connected between the RSC and rotor winding and control the magnitude of current. So this is the simple technique through which we can protect our power converters. Okay, so there is another here in that case we can control the overcurrent, not DC link. So another circuit that is used, coordinated control of series rotor side crowbar circuit and DC link capacitor crowbar circuit. So here we are.
आपकी स्लाइड शायद चेंज नहीं हो पा रही.
That is a problem. ये क्लास में भी प्रॉब्लम होती है कई बार स्लाइड चेंज.
Yes, ma'am. तो participants समझना चाह रहे थे, they are writing, they are not able to see the slide.
ओके ओके ओके, नहीं तो जहाँ नहीं हो रही तो बता देना. हम वो क्या होता है वापिस आके फिर आना पड़ता है, वो क्लास प्रॉब्लम होती है. तो जहाँ अगर विजिबल नहीं है तो प्लीज आप बता दें.
They are writing in chat box में अभी देखा इसलिए जी.
अच्छा, वो एक्चुअल में वो इसमें ना प्रेजेंटेशन मोड में तो चैट बॉक्स में दिख ही नहीं रहा है.
हाँ नहीं मैं आपकी
जब प्रेजेंटेशन मोड में तो चैट बॉक्स नहीं मिलता दिखता है. So this circuit is used to protect the power circuit and to protect the rotor. Here coordinated control of series rotor side crowbar and DC link capacitor crowbar. तो यहाँ पर we have connected one resistor between the rotor and RSC, and chopper is connected at the DC link, so we can protect from both overcurrent and DC link voltage. When there is a normal operation, under the normal condition, circuit breaker is on. Under the normal operation, circuit breaker is on and this resistor is disconnected. This is disconnected. So current will flow from rotor or RSC. आपका जो भी energy exchange हो रहा है rotor and RSC. And this switch is also open and during normal operation. But when there is a fault, there is a overcurrent, this circuit breaker will open. This circuit breaker will open and this resistor will come into the picture. So overcurrent will be protected through this resistor. So overcurrent will be protected, and at the same time, if we are having the over voltage at the DC link capacitor, at that time here we turn on this IGBT. Turn on the IGBT. So extra power or extra energy that is stored in a DC, that will be dissipated through this resistor. So DC link voltage as well as overcurrent voltage both are take care with the help of this coordinated control type of converter. But we have to take two converters at the rotor side as well as at a DC link side. So this is the advantage. And third one is the DC link energy storage system. DC link energy storage system. Here we connect a battery storage system and a converter. This is the circuit diagram of DC link energy storage system. Here we are having two configuration, indirect configuration as well as direct and indirect configuration. In case of direct configuration, this battery energy storage system is directly connected to this DC link capacitor. In case of indirect configuration, this energy storage system is connected to the DC link capacitor through the converter. This is the buck boost converter. So under the normal operation, these energy storage system and converter are disconnected from the DC link. But if there is a disturbance at the grid, then if there is a disturbance, if voltage, grid voltage, if there is a over voltage, then this buck boost converter convert this DC and DC power or energy into the this energy is converted or this energy is fed to the energy storage system. So energy will flow from DC link to the energy storage system with the help of this converter. If there is a voltage low, voltage is low over here, so it can feed the energy from the energy storage to the DC link capacitor, and if there is a voltage dip, it can supply the reactive power to the grid to recover the voltage. So if there is a high voltage, that energy is converted to the energy and which is stored into the energy storage system. If there is a low voltage, then it will supply the reactive power and feed to the grid, and so that grid voltage recover fastly. So this is the DC link energy storage system. In indirect, this energy storage system is connected with the buck boost converter to save the cost or to reduce the efficiency. Sometimes this energy storage system is directly connected to this DC link and supply the energy as and when it is required and consume the energy as and when it is needed. So it works in a bidirectional mode. Another configuration is this direct configuration, where battery is direct connected to the DC link voltage, so it can supply the energy to the DC link capacitor, or it can take energy from the DC link capacitor as and when it is required. And third one is the standalone battery energy storage system. It is not connected between the RSC and GC. It is connected standalone. So when there is a grid fault, grid and voltage dip in a grid, so this circuit feed the reactive power so that voltage will recover fastly. So there are three types of configuration in a DC link energy storage system. Next is the we can use super capacitor also instead of this energy storage system. We can use super capacitor for the fast dynamic response. So we can use this super capacitor also. for the fast dynamic response. It can operate in a buck boost converter. When there is a energy required in a DC link, it will discharge and maintain the DC link voltage. When there is a voltage is high over here, it can take power from energy from the DC link voltage and DC link capacitor and maintain the constant. But due to this dynamic response is very fast, but this super capacitor is costly. Advanced auxiliary energy storage system. Next is the advanced auxiliary energy system. Here we have slide visible.
Yes.
Yes.
Okay, so advanced auxiliary energy system. Here we are having the two circuits, primary circuit and auxiliary circuit. When under the normal operation condition, both circuits are disconnected. But if there is a disturbance, if there is a small disturbance, at that time primary circuit will activate. And this energy is stored in this. This is the voltage source inverter. This is a voltage source inverter, and that is the source of voltage. So at the time of disturbance, this primary circuit will activate, and then energy is stored in the capacitor, is fed to the rotor, and that here we will get the constant voltage over here. But at the time of fault, there are two cases, fault and disturbance. But at the time of fault, when there is a large rotor current and large DC link voltage, at that time this primary circuit will disconnect, and this auxiliary circuit will connect through the S2 bulb. And when there is a over voltage over here, this over voltage is transferred, or this energy is transferred to this battery. So it can operate under the normal disturbance as well as in fault condition. These are the method to protect the rotor or DC link, and we connect the circuit at the rotor side. Next is the stator side external retrofit technique. हम यहाँ पर we connect the circuit at the stator side. So the techniques are series dynamic braking resistor, reactive power compensator, fault current limiter, and series grid side converter. These are the different techniques which we use at the rotor side. First is the series dynamic braking resistor. Series dynamic braking resistor, it is connected with the stator, because stator side हम देख रहे हैं techniques. So here series dynamic braking resistor is connected between the stator and the grid. Okay, and when there is a normal operation, this bypass switch is closed and this resistor will not come into the picture. Under the abnormal condition or fault, this bypass switch will open, and this SDBR, series dynamic braking resistor, will come into the picture. That will be connected between the stator and the grid. So because grid dip in voltage occurs when there is a heavy load, and current will be more at the stator side. So that SDBR, the voltage will drop across the SDBR, because heavy current will flow through this SDVR, and at this point of coupling we experience the constant voltage, because output voltage plus this voltage. So here we experience the constant voltage at the point of coupling. Next is the modulated series dynamic braking resistor. This circuit is connected after the GEC and power grid. So yeah, again when there is a, यहाँ पर we are using only one switch. In modulated series dynamic braking resistor we are using back to back SCR. तो यहाँ पर जैसे ही fault हुआ, if there is a fault in a grid and during normal operation, firing angle 0 and power flow from here DFIG to grid, and this SDVR is out of picture, it is disconnected. But when there is a fault, firing angle will change and जो भी voltage है, it will compensate over here, and here at a grid point, at a point of coupling, we are experienced constant voltage, because जो भी disturbance है, that will be taken care by this controller, and here we are experienced at a constant voltage. So if here we are getting constant voltage, then this circuit will not be affected. So here we connect a resistor at the stator side. Reactive power compensator circuit, all of you know, there are StatCom, DVR, SVC. These are the reactive power compensation device. So reactive power compensation device, these devices are connected at the grid. They are not connected between the rotor side converter or grid side converter. These reactive power compensation devices are connected in the on the grid. StatCom is connected in the shunt of the grid and provide the reactive power if it is required. If there is a dip in voltage, grid voltage, so StatCom will provide the energy to recover the grid voltage. If they're under normal operation, it can the active power from the grid and maintains the DC voltage. So StatCom can absorb or inject the reactive power from the power grid to improve the voltage regulation and stability. SVC, static work compensator. Static work compensators are not used because it cannot provide the harmonic compensation, and cost is more, space requirement is more. So nowadays StatCom is used in shunt with the power grid to maintain the voltage as well as stability. And next is the DVR. You know this circuit also. DVR is connected in series with the grid. That StatCom is connected in shunt and DVR is connected in series. That consists of a VSI injection transformer, and when there is a disturbance in a grid, it provides the reactive power, and under normal operation it takes the active power and maintains the DC link voltage over here. So these are connected at the grid side, not the grid side or converter side. So these are the reactive power compensation circuit. Next is the fault current limiter. Fault current limiter, you know, fault current limiter controls the limit under the disturbance. So here we are using the superconducting fault current limiter. Superconducting fault current limiter consists of coupling transformer, control switch and superconducting coil. So this fault current limiter is connected between stator of the DFIG and the grid. Under the normal operation, this switch is closed and flux between two CTs can offset to each other. Okay, so resistance will be high. At that time, resistance offered this fault current limiter will be high. But at the time of overcurrent, during the transient period, this control switch will open. This control switch will open and this circuit is disconnected from the this circuit is disconnected. Only the circuit will come this this winding and SC superconducting coil. So superconducting coils offer high resistance to restrict the fault current, and stator current overcurrent will be restricted. Initially, superconducting coil does not come to the picture, but जैसे ही fault आगा, superconducting coil offers high resistance and it will control the overcurrent. This is the circuit diagram. We connect the superconducting fault current limiter between the output of DFIG and grid. Instead of this superconducting fault current limiter, we can use a saturated core also, saturated core with superconducting coil. So saturated core may be used instead of superconducting coil. This saturated core is composed of this is the saturated core fault current limiter. Saturated core fault current limiter. Here we are having two coils, AC coils and DC coils. Under the normal condition, impedance of this coil is negligible due to the saturation. But as soon as there is a overcurrent, this core will be unsaturated and offers high impedance. And when it offers high impedance, current will be restricted. So this is the first superconducting fault current limiter. Second is the saturated core fault current limiter. Next and last is the series grid side converter. Here we connect the converter between the in parallel with the DC link and the parallel to the DC link and in series with the grid. Series grid side converter. Here converter is connected in series with the grid. So when there is a unbalanced or grid is unbalanced, it will take the power from the DC link and feed to the grid and maintains the constant voltage over the grid. So it can compensate the voltage, it can take care of the harmonics but take energy from the DC link. So this circuit has many advantages. These are the external retrofits techniques. Internal control techniques. In the external retrofit techniques, cost is more, space requirement is more. We have to use extra circuits, so cost is more. Why not we use a internal control technique? Means we can control the voltage and current at the rotor side converter and grid side converter. So there are three techniques. wind turbine control, rotor side converter, and grid side converter. In wind turbine control, we control the pitch angle. We control the pitch angle, blade pitch angle, so that we can extract maximum power from the supply. We can maintain the tip speed ratio so that we can extract maximum power from the grid. So wind turbine control. Next is the rotor side converter. Instead of external retrofits technique or external instrument, we are having lots of control method. So we can control the voltage or current at the rotor side. So there are two types of control technique: rotor side converter as well as grid side converter. If we control the control the voltage and current at the rotor side converter, then it is known as the rotor side converter technique, rotor side converter controller. There are two methods: linear RSC control method and non-linear RSC control methods. So the linear control methods which we can apply: vector control method, proportional integral and partial sum optimization PSO method, combined vector and direct power control method, and feed forward transient compensation method. These are the linear method which can apply at the rotor side converter, and we can control the current as well as voltage to maintain the voltage, DC link voltage constant, and protect the rotor from the overcurrent. So these are the control technique through which you can control the reactive power and active power at the rotor side as well as the DC link. So these are the linear method. There are some non-linear method because linear method is not very accurate and response is slow. So there are non-linear method also: sliding mode controller, decentralized non-linear control, input to state stability based control, fuzzy logic control, and interval type 2 fuzzy PI controller. I have given the reference number over here. If you want to do work, you can refer these paper, because 1.5 hours it is not possible to discuss all these methods. So I have given the references for linear control and non-linear control. You can refer this paper if you want to work on this topic. Grid side converter. Here we have control at the grid side converter. Here we have the controller at the grid side converter. So same techniques we can over here. We can control the current and voltage at the grid side so that we can maintain the DC link voltage as well as overcuts. Again, I have given the reference number. The method is coordinated control method composed of PI controller and resonant compensation, PI regulator and dual frequency resonant, discrete time inversion, optimal control method, sliding mode controller, and non-linear coordinate. Again, I have given the reference number. You can refer these papers and you can do your research. Next is the hybrid control technique. We know that one technique has advantages and disadvantages. So if we combine advantages of two techniques and emerge one technique, then it is known as the hybrid techniques. So there are some hybrid technique also: internal control strategy and facts control. So we can take advantages of both the techniques: facts and protective circuits, internal control strategy. So these are the combination. By taking two techniques, performance definitely will improve. So hybrid techniques, you can take this topic also for your research work. conclusion, a comprehensive discussion has been done on the different techniques used to enhance the LVRT capability of wind turbine. The external retrofit techniques are implemented at the rotor side as well as at stator side in the existing wind farm. And internal control techniques are applied to the rotor side as well as grid side converter in a new wind farm. This is the important point, and hybrid control techniques can be employed to increase the overall performance of the DFIG wind turbine. These are the references which I have referred.
Thank you. Thank you very much, ma'am. Now we may have question hour session. If participants are interested to ask any question, ma'am, regarding their research or any question. Madam, can we allow participants for question?
Yeah, I will try to give.
Or do you want to take a break? It has been a long session, madam.
No, I don't want to take rest.
Okay, so we can have a questionnaire session. If any participants have any queries, please be brief and you may ask your question to ma'am.
Sumant, he has written, please provide the PPT. Sumant, you can take PPT from the Bhupendra. I will give presentation with this PPT to the Bhupendra.
Yes, ma'am. I will share this on the WhatsApp group and also to the mail.
Because I am faculty, so I want that maximum people will be benefited by this presentation.
Yes, ma'am. We will share this recording also. We will share this recording also on our YouTube channel.
Any query?
Any queries?
Hello.
From anybody?
Hello.
Yeah.
Hello,
Yes.
madam. Madam, good afternoon, madam.
Good afternoon.
Myself, Sumant, madam.
Yeah.
As of now, in DFIG, in RSC and GSC, we prefer to design PA controller. Now, is there any change? Is there any possibility to include PID controller, any other FO PID controller? If it is possible, what is the advantage of PID controller as compared to the PI controller, madam?
There are advantages of proportional, integral, and differential controller. If we want to improve the steady state condition or steady state output, then you have to take a proportional. If you want to improve the transient condition, then you have to take integral controller. So you can take PID controller, but differential controller does not give any correction factor. So mostly PI controller is preferred. D controller is not preferred.
Okay. What about FOPID controller, madam?
Transient condition.
Okay. What about FOPID controller, madam? Fractional order PID controller.
Which one?
Fractional order PID controller. FOPID controller.
SO?
FO. Fractional order PID controller.
I don't know because this is not my area.
Okay, sure, madam.
Good afternoon, madam.
I
Myself,
hope you are not having any more questions.
can I ask one question? Actually, when we talk about rotor side converter, then what is the impact of pitch angle?
Pitch angle.
Yeah, right.
Pitch angle of the rotor blade.
Blade.
So we use hybrid controller. We control the blade pitch angle as well as rotor side controller. Initially, rotor side controller will activate, and there is sufficient time to activate the blade pitch angle. So in hybrid, we use both wind side converter और as well as rotor side converter. हम because जैसे ही हमारी स्पीड इंक्रीज होती है, आपका स्पीड जैसे ही इंक्रीज होगी एक सर्टेन लिमिट से, तभी आपका ब्लेड पिच एंगल चेंज होगा, ब्लेड पिच एंगल कंट्रोल जो एक्टिवेट होगा। तो इनिशियली हमारा क्या होगा कि रोटर साइड कन्वर्टर एक्टिवेट होंगे और पैरेलल में हमारे विंड ब्लेड पिच एंगल भी एक्टिवेट होगा और हाइब्रिड कॉम्बिनेशन हमारा एक्टिवेट होगा। दोनों ही जैसे ही हमें ओवर स्पीड मिलेगी तो हमारा जो ब्लेड स्पीड कंट्रोलर है वो भी एक्टिवेट हो जाएगा और स्पीड हमारी विंड की कम हो जाएगी, सो दैट वी विल हैव लेस पावर फ्रॉम द विंड और हमारा जो सिस्टम है दैट विल बी प्रोटेक्टेड।
ओके ओके, थैंक यू मैडम, थैंक यू।
Any other questions? So I hope we are not having any questions. So I formally.
Sir, good afternoon.
नमस्कार मैडम, कैसी हैं मैडम? आई एम सॉरी, मैं जब आपका सेशन चालू हुआ तो नहीं आ पाया, एक्चुअली मेरी क्लास थी, जैसे ही खत्म हुई तो मैंने आपका सेशन ज्वाइन किया। थैंक यू मैडम फॉर
नो प्रॉब्लम
सेशन मैडम, थैंक यू।
Thank you very much for calling me.
It's our pleasure, madam. So, open, should we formally close the session?
Yes, sir, we can close.
Okay, thank you.
I express my sincere thanks to Sushma Madam for delivering us a very wonderful lecture on the technologies involved in wind power, especially the power electronic interface, the power control, the reactive power management, and lots of areas. I hope many researchers and many budding researchers would be benefited by these topics, and many queries may have been satisfied. Thank you once again, madam. Thank you.
Thank you very much. Thank you.
Thank you, madam. Thank you.
Now we will be sharing. Sir, do you have? Now we will be sharing another the same Google form that may be used as a feedback as well as your attendance.